Hello everyone, I am Ankan and today I am going to explain the solution of the problem uninteresting number. So in this problem, we are given a number n with length no more than 10 power 5 and we can perform the following operation any number of times. So in one operation, we can choose any digit of our given number and square it and then replace the original digit with the result. And it is given that the result must be a digit. That is, if we choose digit x, then the square of the digit x, that is x square, must be less than 10. That is, x square should be a single digit. So this is the operation that we can perform. And we have to predict whether our given number can be converted into some number which is divisible by 9. So this is the problem statement. Now let's look at the constraints. So we are given t test cases and the value of t can be 10 power 4. And in each test case, we are given a number n, and the number of digits in our number can be at max 10 power 5. And it is also given that the sum of the lengths does not exceed 10 power 5 across all the test cases. So for each number n, we have to print yes or no, whether the number can be converted into a number which is divisible by 9 after performing some number of operations. So this is the expected output. And let's look at some of the test cases. So in the first test case, we are given 123 as our n. So let's analyze this. So we have n equal to 123. Now we can choose any digit in our n and replace it with the digit square. So let's say we choose the first digit, that is 1. The square of 1 is 1 again. So no matter if we choose this digit or not, our answer would be, our result would be the same number again. And now let's check if this number is divisible by 9. So for the divisibility of 9, we have the rule that we can take the digit sum of our given number and check whether it is divisible by 9. So let's check the sum of the digits. So we have here 1 plus 2 plus 3, which is 6. So 6 is not divisible by 9. So this can't be our answer. So now let's move to the next digit. So let's check if squaring the digit 2 gives a number that is divisible by 9. So let's check that. So we will get 1. So 2 square is 4 and we have 3. So 143 is also not divisible by 9 because the sum of the digits is equal to 8 and 8 is not divisible by 9. So this also can't be our answer. Now let's move to the next digit, that is 3. So let's square it. So we'll get 129 and the sum of the digits is 12 and 12 is not divisible by 9. So this also can't be our answer. And the other possible cases, we can square all the digits. Then we can get 1, 4, and 9. So in this case also, the sum is not divisible by 9. So we will get 14 as our sum, and it is not divisible by 9. So this is also not a valid answer. And notice that we can't perform any further operations on this. Because if we try to, let's say, square the digit 4, we will get 16, which is two-digit number. But according to our problem statement, x square must be less than 10. So it won't be satisfied. So for the this n, that is n equal to 123, our answer is no. We can't transform it to a number which is divisible by 9. So we print no as our answer. Let's look at the next test case also. So we have 3, 2, 2. So for 3, 2, 2, let's try to analyze it. So we can replace 3 with 3 square. So we will get 9, 2 and 2. So this is the sum of the digits is 13 here, which is not divisible by 9. So we eliminate this. Next we have 2. So let's square it. So we'll get 3, 4 and 2. Now if you see the sum, we have 9. So 3 plus 4 plus 2 is 9, which is divisible by 9. So this number is divisible by 9. Hence, our answer for this test case is yes. So we print yes. So now let's try to generalize the problem. So let's say we have some digits. Let's say we have n digits in our number. And for every digit, we have two choices. So either we can square this digit or leave it as it is. So let's say our we have d of I. Then we have two choices. So either we can square it or leave it as it is. So the two choices are either we can leave it as d of I or we can square it. So d of I square. And the condition for squaring is it should d of I should be the square of d of I should be less than 10. So for which possible digits is it is true? So for digits like 0, 1, 2, and 3, this condition is true. The digit square is less than 10. So any value greater than 3, like 4, 5, and 6, if we do the square, we will have two digits, which is not a valid square operation that we can perform as per our problem statement. So yeah, like we have two choices for each digit, d of I. Uh, if we try to do it for every possible uh, possibilities, then we will get 2 power n combinations. So there are 2 power n choices that we can have in total because for every digit we have two choices and there are n digits. Then we will get 2 power n choices, and that this won't be enough for our given constraints because our constraint is 10 power 5. The n value is 10 power 5. So our it would take a long time and we'll get TLE. So how to optimize this? So to optimize it, we can use DP. So let's see how we can solve it using DP. So for the DP state, we can maintain. So DP will maintain two states. So first state would be the index, the current index. So let's denote it with I. Index is nothing but the uh, digit which we are iterating through. So the first digit would have I equal to 1, second one would have I equal to 2, so on. And let's also keep track of the current remainder. So let's say we are at this index, index 4, then what is the remainder of the sum of the previous digits when divided by 9? So let's keep track of this. So let's say it is R. So using these states, we can uh, iterate over all the indices and all possible remainders and get our answer. So if any of the state reaches with remainder equal to 0 till the end, so till if it reaches n and the remainder is 0, then we have our answer as true and we return true. So using this states of DP, we can solve this problem. Now let's look at the code. So initially we have taken our number as input. So since the number can be large, I have taken it as a string A, and I have taken the length of our string as n. And then I have initialized the DP of size n into 9. since there are n indices and nine reminders possible. So I have taken uh, n into 9 as our DP. And initially it is set to -1. That is, the current state is not visited yet. Once we visit it, we will update it with the particular value. And next, we recursively iterate over all the indices and all the possible reminders. So let's go from index 0, and initially our reminder is 0. So let's go to the recursive function. So we have the base case. So once we reach the end of our number, that is in index reaches n, then we will check if our remainder equal to 0. If our current remainder is equal to 0, then that means the number is divisible by 9 and we return true. So this condition will return true if the remainder is 0, else it will return false. Next, we will check if our current state, that is our current index and current remainder, has already been visited. If it is visited, then we return dp of index comma remainder. So that means this state is already visited since it is not equal to -1, and we return the dp value. And if it is not visited, we will check both the possibilities. So since we have two possibilities here, so either take the current digit or take the square of the current digit. So we will take the both the possibilities here. So here we will go to the next index. So in the first possibility is like we take the current digit and move forward. So we update our reminder by reminder plus digit modulo 9. And if this returns true, if this function returns true, then that means it is divisible by 9 and we update our answer as true. So initially answer is false. And if this function returns true, then we update our answer. So once this is for the first condition or the first possibility. Now let's look at the second possibility. So for the second possibility, only for digits less than 4 we have to consider because only these digits we can square. So let's check that. If digit is less than 4, then we take the square of the digit and add it to our remainder and update the remainder by modulo 9 by applying modulo 9. And we go to the next index, index plus 1. And if this function returns true, if this function returns true, then we update our answer as true. And yeah, now both the possibilities are covered. Now we'll update our DP value. So we update our DP value with our answer and we return this answer. So this is the solution. So thank you so much for listening to this and goodbye.